This is pneumatics question 12 from past paper 2016. It is a descriptive question that we're looking for first of all, as opposed to a calculation. It's a 3-mark question. So it says mechanical model of a dinosaur uses pneumatics to control its movement. Part of the pneumatic circuit is used in the model as shown below. So we've got our circuit, pneumatic circuit, and the question is describe using appropriate terminology the operation of the circuit. And it starts you off, so when a signal is sent from the microcontroller, so it gives you microcontroller, gives you valve 1, valve 2, valve 3, component 4 and cylinder A. Now it's really important that you're able to determine the type of valve they are. So valve 1 is a 3-2, valve 2 is a 5-2, this component here is a reservoir, okay, component 4 is a unidirectional restrictor, and valve 3 is a 3-2 valve. Cylinder A is a double acting cylinder. Now the way we can tell that is because it's got 2 ports connected into it, but there isn't a spring which is going to cause it to return on its own. So the first thing we need to do is also identify where this microcontroller is. So it's coming from here. Our circle with the dot is our main air. Our triangle is our exhaust. The little squiggle at the bottom of the 3-2 valves is your spring return. And then we've got a 5-2 with 2 exhaust ports and 1 main air port. The important thing to think about here is following the path of the circuit. So where is the air going? So when a signal is sent from the microcontroller, so it's coming from here, it's actuating valve 1, the 3-2 valve, which causes a dashed line, which is pilot air. So pilot air goes into the left hand side of the 5-2 valve, which means it's flowing, it's pushing in this direction. The main air is then allowed to flow into the left hand side of the double acting cylinder, so it's coming up to here, and it is causing the double acting cylinder to outstroke. So when air goes into this side, it will outstroke. When this outstrokes, it will actuate the roller on top of valve 3, which will then, so this one's been actuated, which means the pilot air can then go into component 4, unidirectional restrictor, and the reservoir. Both of these components together cause a time delay, and then what will happen is it will go into the right hand side of the 5-2 valve and into the right hand side of the double acting cylinder, filling this end with air, causing it to instroke. And that is all you need to talk about for this question. So where you get your marks, you're looking for how you are outstroking it first in the first instance. So air flows into the double acting cylinder, causing it to outstroke. Okay, that would give you your first mark. You can then say valve 3 is actuated. And then you've got pilot air into, you can either mention component 4, the reservoir, or you can say the air flows into a time delay. I would personally say that it flows into unidirectional restrictor and the reservoir. So pilot air into unidirectional and reservoir, causing time delay, and that would give you your second mark. And your third mark is from saying that the pilot air then goes into the 5-2 valve, causing the double acting cylinder to in stroke. So air flows into the 5-2 and into, I'm just going to shorten it, so RHS for right hand side, causing in stroke. And that would be your third mark. So you're basically getting a mark for saying how the double acting cylinder outstrokes, how it instrokes, and then this little part here causing your time delay. So while this has kind of fallen off the screen, I will move the camera down, and that is what I would have as my answer. Now obviously your answer is not going to be exactly the same as that, but you should have statements, descriptions that link into each of these 3 points.